It has been right around a week since NASA's most recent SLS launch attempt, a part of Artemis I. This was the second attempt and ended up being scrubbed due to a liquid hydrogen leak on the quick disconnect. In the time since then, the agency has continued to work on these issues along with the future plan for the next generation launch vehicle. NASA decided to work on the issue at the launch pad and mobile launcher before they inevitably roll the rocket back into the vehicle assembly building. Just yesterday, they replaced the seals on the core stage of the rocket where the issue was identified. On September 3rd, when the issue occurred, the agency tried multiple quick fixes in order to salvage the launch, but were unsuccessful. Thankfully, now with full access to the rocket and surrounding ground equipment, they are reporting a lot more success in regards to repairs and trying to fix the issue. However, this has delayed the first launch quite a bit as NASA now has to wait for the next launch period. Here I will go more in depth into the progress of repairs, what's next for SLS, future launch attempt dates, and more. One week ago, during the second launch attempt of Artemis I, more problems arose. Specifically, after the third failed troubleshooting attempt, a liquid hydrogen leak occurred again and NASA scrubbed the launch. At the time, multiple efforts to address the area of the leak by reseating a seal in the quick disconnect, where liquid hydrogen is fed into the rocket, did not fix the issue. This was the information the agency left us with on September 3rd. However, a few days later on the 6th, NASA gave us more information. Based on the results in the failed fix attempts during the countdown, the agency decided to replace the seal on an interface called the quick disconnect between the liquid hydrogen fuel feed line on the mobile launcher and the Space Launch System rocket while at the launch pad. Not long after the launch was scrubbed, NASA reported the repairs were necessary and they were not sure whether the repairs would be made on the launch pad or in the VAB while the batteries were being reset. Days later, NASA decided that completing at least some of the repairs at the launch pad would be beneficial. They highlighted that performing the work at the pad requires technicians to set up an enclosure around the work area to protect the hardware from weather and other environmental conditions, but enables engineers to test the repair under cryogenic or supercooled conditions. Performing the work at the pad also allows teams to gather as much data as possible to understand the cause of the issue. NASA also pointed out that teams may return the rocket to the Vehicle Assembly Building, or VAB, to perform additional work that does not require use of the cryogenic facilities available only at the pad. It's important to point out that no matter what the result of the repairs is, or whether NASA decides to complete them, the Space Launch System must return to the Vehicle Assembly Building before the next launch. In order to meet the current requirement by the Eastern Range for certification on the Flight Termination System, NASA would need to roll the rocket and spacecraft back to the VAB before the next launch attempt to reset the system batteries. The next update from the agency came only a few days ago on the 8th. At this point, technicians constructed a tent-like enclosure around the work area to protect the hardware and teams from weather and other environmental conditions out at Launchpad 39B. They disconnected the ground and rocket side plates on the interface, called a quick disconnect, for the liquid hydrogen fuel feed line, performed initial inspections, and began replacing two seals, one surrounding the 8-inch line used to fill and drain liquid hydrogen from the core stage, and another surrounding the 4-inch bleed line used to redirect some of the propellant during tanking operations. Two tail service mass umbilicals connect from the zero-level deck on the mobile launcher to the SLS rocket core stage aft section. These umbilicals are about 33 feet tall. They provide liquid oxygen and liquid hydrogen fluid lines and electrical cable connections to the SLS core stage engine section to support propellant handling during pre-launch operations. The umbilicals tilt back before launch to ensure all hardware safely and reliably disconnects and retracts from the rocket during liftoff. This is where SLS's issues have been in regard to hydrogen leaks. The agency also pointed out that the SLS rocket and Orion spacecraft are in good condition while remaining at the launch pad. This leads us to the most recent update that came just yesterday. After disconnecting the ground and rocket side plates on the interface, teams have replaced the seals on the Space Launch System rocket's core stage associated with the liquid hydrogen leak detected during the Artemis I launch attempt. They reported both the 8-inch line used to fill and drain liquid hydrogen from the core stage and the 4-inch bleed line used to redirect some of the propellant during tanking operations were removed and replaced this week. Now that we know exactly what repairs have been made over the last week, we can take a closer look at what's next for the Space Launch System and when we should expect to see it lift off. A few days ago, NASA submitted a request to the Eastern Range for an extension of the current testing requirement for the Flight Termination System. NASA is respecting the range's processes for review of the request, and the agency continues to provide detailed information to support a range decision. In the meantime, NASA is instructing the Artemis team to move forward with all preparations required for testing, followed by launch, including preparations to ensure adequate supplies of propellants and gases used in tanking operations, as well as flight operations planning for the mission. Yesterday, the agency tweeted saying, "Engineers are making progress repairing the area where a liquid hydrogen leak was detected during the Artemis I launch attempt September 3rd, and NASA has requested 2 September launch opportunities." These 2 launch opportunities include a 2-hour launch window on September 23rd and a backup on September 27th. This means the soonest we could see the SLS ready to lift off is around 2 weeks from now. NASA's teams internally are preparing to support additional dates in the event flexibility is required. The agency will evaluate and adjust launch opportunities and alternate dates based on progress at the pad and to align with other planned activities, including DART's planned impact with an asteroid, the West Coast launch of a government payload, and the launch of Crew 5 to the International Space Station. In addition, coming up, technicians will reconnect the umbilical plates and perform inspections over the weekend before preparing for a tanking demonstration as soon as Saturday, September 17th. This demonstration will allow engineers to check the new seals under cryogenic or super cold conditions, as expected on launch day and before proceeding to the next launch attempt. During the operation, teams will practice loading liquid hydrogen and liquid oxygen in the rocket's core stage and interim cryogenic propulsion stage and getting to a stable replenished state for both propellants. Teams will confirm the leak has been repaired and also perform the kickstart bleed test and a pre-pressurization test, which will validate the ground and flight hardware and software systems can perform the necessary functions required to thermally condition the engines for flight. In these tests, before the massive amount of fuel is delivered to the engines, SLS engineers chill down the engines to thermally condition them to receive the propellant. The engine thermal conditioning is kick-started by delivering liquid hydrogen to the engines at the same time the liquid hydrogen core stage tank is being filled. This procedure was developed during the core stage green run testing when all 4 engines were chilled and ignited, just as they are during launch. By doing this early in the launch countdown, engineers can evaluate data and ensure that the engine components are sufficiently saturated with supercold liquid hydrogen that chills them before they proceeded with the terminal countdown leading to launch. The core stage bleed valve allows hydrogen to flow through the engines and thermally condition them by starting to chill them down. Following the test, teams will evaluate the data along with plans for the next launch opportunity, all of which are expected to happen not long from now. If successful, the final steps will be a rollback to the VAB, then to the launch pad, ready for another launch attempt. The Space Launch System is NASA's next-generation launch vehicle working to try and return humans to the surface of the Moon. Over the past few months, we've watched the launch vehicle prepare for its first launch. Recently, it scrubbed 2 launches due to liquid hydrogen leaks that are being repaired as we speak. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.